Hello. Now we are going to look at problem solving involving fractions. So for problem solving type questions, we're going to be given a story. It might be involving a shape. In this case, it is just involving stories in English. And we're going to have to interpret those stories. We're going to have to break them down into maths, make sure we understand what the numbers we're given mean and how they relate to each other. And then we're going to be able to get into doing the maths of it. And the structure that we have been learning for our less wordy questions really helps us here. To begin with, let's have a look at this one. So we have Roy studies some of his subjects for 40 minutes per week. Kay studies some of their subjects 2 hours per week. Write Roy's study time as a fraction of Kay's. So we're comparing Roy's study time to Kay's study time. So if we just said, well, let's describe the situation. We are asked to put Roy's study time all over Kay's study time. So we want to put the or here stands for Roy's study time. The K here stands for Kay's study time. We want to write a fraction like this, and all of our fractions we're going to try and simplify. So that's what we're aiming for. If we just write down 40 all over 2, this doesn't give a good relationship between Roy's study time and Kay's study time because we're not counting in the same units. It makes it look like Roy did a huge amount more study than Kay did, when in fact it's the other way around. So it's really important whenever we're trying to do practical problems that we keep track of the units we're talking about and make sure that we're counting in the same thing. So here we have 40 minutes being talked about. And here we have 2 hours being talked about. So we need to compare like with like. So we need to turn this 2 hours into minutes would be the easiest way to do it. 40 minutes can be turned into hours, but it makes life a little bit more complicated. So let's turn everything into minutes so we can do a direct comparison. So we have 2 hours and we want to turn it into minutes. So we know that there is 60 minutes in each hour and we have 2 hours. Then we would have 40 minutes divided by 2 groups of 60 minutes. And that's going to give us 40 minutes compared to 120 minutes. And now we have like compared with like, but we don't have a simplified fraction. There's obvious common factors between 40 and 120, and the biggest one is actually 40. So we can write that is the same as 40 times 1 all over 40 times 3. And we're still dealing with minutes compared to minutes. 40 divided by 40 is 1, so we end up with one group of 1/3, so we end up with 1/3 as our final answer. And often we wouldn't write minutes over minutes, but we can if we're more comfortable with it. The way we would tend to say this is that Roy studies for 1/3 of the time that Kay does. Let's have a look at this situation here. So we have Corey ate 2/5 of a box of 20 sweets. Moya ate half of the box. Abdi ate the rest. How much did Abdi eat? Now this question is a little unclear in that does it mean what fraction Abdi ate or how many sweets did Abdi eat? We actually have enough information to find both, so we're going to find both. We'll look at this from the point of view of finding just the numbers to begin with, and then we'll look at a more advanced way of thinking about the question that'll really help us in the long run. If we know that Corey ate 2/5 of the box of 20 sweets, well, that means that Corey's amount, so the number that Corey ate, the hashtag symbol we often use in maths to mean a number of something. It's often called the cardinal number, but for right now, it's the number that Corey ate. And that's going to be 2/5 of 20. So 2/5 of 20 is the amount of sweets that Corey ate. Well, of means multiply, so we're talking about 2/5 of 20 would be 2/5 multiplied by 20. This is fraction multiply, so we end up with 20 all over 1. Top by top, bottom by bottom. Allows us to work out the number of sweets that Corey ate is going to be 40 all over 5. There's a common factor of 5 here. Now, 5 goes nicely into 40. You can just write down 8, but we can also think about it in terms of common factors. We have 5 by 8 would give us 40 all over 5 by 1. 5 divided by 5 is 1, and we're just left with 8 over 1 is 8. So we can always simplify our fractions using our common factors. So we now know that Corey ate 8 of the sweets. Moya ate half of the box. The amount that Moya ate, the number of sweets that Moya ate was half of 20. So we know that that's going to be half of 20 is a half multiplied by 20. So we end up with 1 times 20 all over 2 by 1. So we end up with 20 all over 2. And we can take out a common factor, or we can just say that half of 20 is going to be 10. So Corey ate 8 sweets. Moya ate 10 sweets. If there were 20 sweets in total, how would we figure out how many Abdi ate? Well, if we think about the amount that Corey ate, the amount that Moya ate, and the amount that Abdi ate, they must all add up to 20. So now we could add these up and get 18 and then just take that away from 20. So we may as well write that down. What we might think to do is say that Abdi's number is just going to be the 20 sweets minus the 10 sweets minus the 8 sweets. This might instinctively be how we would get our answer, and then the number of sweets that Abdi ate would just end up being 2 sweets. Where is this argument coming from? It's how we would often instinctively tell ourselves the story, but it's coming from somewhere, and we can explain where it's coming from better. What we mean when we have the total number of sweets and we take away Corey's amount and Moya's amount is that if we added up all 3 of the people's number of sweets that they'd eaten, we'd have to get a total of 20. So we can write that argument out more clearly by saying that the number of sweets that Corey ate plus the number of sweets that Moya ate plus the number of sweets that Abdi ate would have to all add up to 20 sweets. That's really where this argument is coming from. And then we would be able to say, well, we know the number that Corey ate is 8. We know that the amount that Moya ate is 10, plus the number that Abdi ate is what we want to find out. We can add up our 10 and our 8. So we know then that the number that Abdi ate must be 2, because 18 plus 2 would give us 20. Fundamentally, that's where the business of saying we have Abdi's amount is 20 minus 18 is 2. That's where that argument is coming from. And in maths, the clearer we can be about our thinking, the clearer we can structure our thinking on the page, the better off we are. So this is a better way of describing why Abdi got 2 sweets. It describes our thinking much more clearly than when it's mostly done in our head if we just wrote down something like this. So we want to try and avoid this way of writing and see if we can be clearer about our storytelling. We could also do this directly using the fractions instead of finding out the numbers and then working out Abdi's number of sweets from knowing the fraction that Abdi ate. So we could start and say Corey's amount plus Moya's amount plus Abdi's amount must all add up to 1 complete box of sweets, or 20 out of 20 if we wanted to say it that way. So we'd have 20 sweets out of 20, or it would be 1 complete box of sweets. So you can think about it either way. In this case, the letters are standing for the fractions of the box that Corey, Moya, and Abdi ate. So they're standing for something different here. This was the number that Corey ate. This is the fraction that Corey ate. So we have 2/5 for Corey's amount. Moya ate a half. We don't know what fraction Abdi ate. And we know that this should all add up to all 20 of the 20 sweets being taken into account. Now we have 2 fractions we want to add. So we want to find the total fraction that Corey and Moya ate. So we can see that we have 2/5 and 1/2. we need to compare like with like. So we're going to have to get the same denominator. The lowest common denominator that is going to work for us is 10. We could also go to 20 so that we're comparing to the total number of sweets. Either would be fine. I'm going to go to 10 because those are the numbers that I'm dealing with right here. We have 2 over 2. And the fraction 5 over 5 will allow us to change both of those into tenths. So we have 4/10 of the sweets were eaten by Corey and 5/10 of the sweets were eaten by Moya, and then Abdi's fraction, and that has to add up to our total of 20 out of 20 or 10 out of 10. It's all just 1. We then say we have 4/5 and 5/5, so we have a total of 10ths I should say. 4/10 and 5/10, so we have a total of 9/10 plus Abdi's amount. Abdi's fraction should add up to 20 out of 20 or 10 out of 10. So if I change that to 10 out of 10 just to save on the space, 20 out of 20 and 10 out of 10 are both just 1. So if we know that 9/10 were eaten by the other two, Abdi must have eaten 1/10. So Abdi would be 1/10 and then 1/10 of 20. The number that Abdi ate would be 1/10 of 20, which is going to end up being 2 sweets, just like we got before. So those are 2 different perspectives we can take, and both are very important that we can think through. Now Mo, for another question, Mo did half of the work for a project, Ace did a third of Mo's work, and Una did the rest. What fraction of the work did each do? Now we have to work directly in fractions because we don't know a total number of hours or weeks that the people spent on the project. So we know that Mo's fraction plus Ace's fraction plus Una's fraction must all add up to the total of the project, which would be 1 complete project. Mo did half of the work, so we know Mo's fraction, we just keep the single letters, Mo did half of the work, so that's going to be half of the complete project. Ace did a third of Mo's work, so they did a third of Mo's work. We know that Mo did half of the work, so that would be a third of a half. Top by top, bottom by bottom, we would end up with that being 1/6. So we know that Ace did a 1/6 of the work, and we are then looking for Una's fraction. So even if we can't figure out Una's fraction, by telling the story of how Ace's amount relates to Mo's amount, we're able to figure out most of the question. We have 2 of the 3 people figured out. So now we go back to this statement here and see if we can use it to figure out Una's amount. So we have Mo plus Ace plus Una must all add up to the total project. Mo did half, Ace did a 1/6, a third of a half, and Una's we don't know, and that adds up to our total. We want to add our 2 fractions, so we need the same denominator. 1/6 is fine, but we need to multiply here by 3 over 3, so we end up with a denominator of 6 here. And we end up with 3/6 plus 1/6 plus Una's fraction is 1, and we end up with 4/6 plus Una's fraction must add up to 1. 4/6 can be simplified. We can take out a common factor of 2. And we end up with 2/3 plus Una's fraction must be 1. So we can see that Una's fraction must be 1 would be the same as 3/3. The same as 3/3 would be our total. Minus 2/3, logically enough, that must be 1/3. So Una did a third of the work for the project. And that is how we can do problem solving with fractions, and that is what we need for now.